Jesse Smith doing my evolution project. The four principles of natural selection are members of a population have to have heritable variations, so you can't have asexual reproducers in natural selection. They must be sexual reproducers. The population must produce more offspring than the resources of an environment can support. Individuals with desirable traits survive and reproduce, whereas individuals with less desirable traits do not. And over time, the population must tilt in favor of the desirable traits, and so that the overall population becomes adapted. An example of that would be the finches of Galapagos. Any individual set of finches will work. You just use the example that the original finches that came to the islands had to change and adapt to whatever island they were on, to an extent where finches that weren't able to adapt no longer were the same species and don't recognize each other. The evidences of evolution. There is fossil evidence, biogeographical evidence, and anatomical evidence. Fossil evidence is mostly comes down to the fact that you can look back and see fossils of older versions of animals that aren't exactly the same, have slightly different features, maybe some that went one direction and died out, or some that show the direction that the animal ended up eventually going in. Biogeographical evidence is there's different plants and animals that are similar, but they're located in different parts of the world. They're similar, like the example I have is cactuses that grow in the United States and euphorbia, which grow in African deserts. They're both very similar plants, but they're totally different species. They don't reproduce the same or anything like that, but they have similar traits and they're in different parts of the world. But those parts of the world are very similar. There's anatomical evidence as well. You can see it. All mammals basically have very similar bone structures. So you can see, like, we have similar bones in our body that aren't necessarily the same, but if you look back all the way back to our embryo even, they're all extremely similar and have basically the same shape. My specific species I picked was the giant squid. The adaptations it has is it's extremely large in size. Along with all the other natural squid adaptations with the beak and the squid tendrils, etc. They move the same as other squids, just they're extremely large and they live in the deep sea. I think the reason that they are so large is probably because they only have one known natural predator, which is the sperm whale. It's probably suited to its environment just because it has such a low number of predators. It can be the largest animal in its area that eats whatever it wants that's smaller than it in the deep sea. Not too much is known about giant squid, like their actual population is hard to tell. I'm going to assume they're not endangered just because it's hard for us to study them since they're in the deep sea. If the climate change, what climate change can be for the organism, if anything, it might be good for it, I think, because I think climate change might negatively affect sperm whale, but giant squid are deep enough in the ocean that it might not affect them too much, so they might just thrive and get bigger and more populated. That's it for my evolution project.